Yesterday we started working with 45, 45, 90 triangles, and we learned the basic properties that that triangle has, okay? And then we practiced a couple problems where we just practiced using those properties, okay? So today we're still working with that type of triangle. However, now we're going to start being given different pieces of information, and we're going to learn how to still use these properties to find the sides of the triangle, even with that different, I guess, piece of information. Okay, so review this and the problems from yesterday if you need to, but now we're going to go straight to examples and learn how to use those properties. So if you want to add these to the notes from yesterday, you can do that. You can just follow along and watch. Okay, so notice you're still going to look to see if it's a 45, 45, 90. And notice you have a 45, you've got a 90. And so we discussed yesterday that would actually make the other angle be 45 because the angles have to add to be 180. Okay. And so now you're going to look at what you're given information-wise. So today, notice this is going to be a little different because we're given, maybe if you kind of look closely, we're given a little bit different information than we were yesterday. So if you look at this problem in number 5, you'll notice that we're given the hypotenuse this time, okay? And we have to find x and y, which notice they're both the legs. So the easy thing that we'll be able to do with this is once we find one of the legs, if you remember from yesterday, the other leg will be the same. And so that'll be easy once we figure out one of the legs, okay? However, we have to work with, well, how in the world do we backtrack to find the leg, okay? Well, the first thing is remember that the hypotenuse is equal to one of the legs times the square root of 2. So if you kind of think about it, what we did to the leg to get the hypotenuse was we multiplied by the square root of 2. So one way that you can think about this is to kind of backtrack, to work backwards. You would kind of do the opposite of what's being done. So since we had to multiply by the square root of 2 to get the hypotenuse, you would technically have to divide by square root of 2 to kind of work backwards and get the leg, okay? And so if you knew that, then you could just go ahead and take this, divide by the square root of 2, and then you would have the leg, okay? Now, if that is kind of troublesome and you're like, oh, I don't understand that, you could also use this formula and you could just plug in your information that you're given into the formula and you'll find out that it actually has it kind of does it for you, okay? So notice this is the hypotenuse of your triangle. This is a leg, and then this is your other leg, okay? And so if we have to find what the leg is, well, the hypotenuse, I'm going to plug in what the hypotenuse is. The hypotenuse is 15 square root of 2. And then notice I'm just using that equation and I'm plugging in. And we're looking for the leg, okay? Now, you can find either one of those. So let's say that we're going to find x first. So my leg is x, and then that's times the square root of 2. So all I've done is I've plugged it in that equation. And now I have to find and solve for x. So notice what I was talking to you about before is we're going to have to be able to solve for x, we're going to have to divide by the square root of 2 because that's the opposite of what's being done to it. So when I divide one side, I have to do the same to the other to keep the equation balanced. And so when I do that, those will cancel out. And so x would be by itself over here. And then when I have a square root of 2 over the same thing, anytime you have something over the same thing and being divided, that actually kind of goes away because it's the same thing as 1. And so you're just left with 15. And so x is equal to 15. Okay, and so you can plug it in the formula like I did, or you can think about, okay, what did I do to get there? How do I work backwards? And so notice what I was talking about earlier is if you think to yourself, okay, I took one of the legs and multiplied by the square root of 2 to get there. then all I have to do to work backwards is do the opposite of that. I'd have to divide by the square root of 2, which is kind of what happened here. And if you do that, you end up with the same answer. You end up with 15. Okay, so x would equal 15. Okay, and then remember the legs are the same. So if x is equal to 15, then the y, which is also a leg, would be 15. So x equals 15, y equals 15. So there we go. Okay, all right, let's do another one. So what if, and I just realized, oh my goodness, I did not give you enough information for this one either. So let's say, let me add some marks here. Let's say that that's marked in that way. So remember, when it has two sides equal and that it's got a 90-degree angle in the middle of them, that means that these two angles have to be the same because the opposite angles of those sides in a triangle have to be the same. So they would have to be 45, okay? And so with this one, we just have to find this side right here, which notice that is a leg because it surrounds that 90-degree angle, okay? So we're just trying to find an x, which is a leg, and we're given the hypotenuse, okay? So think through, because it's the same scenario as what we had up here, think through it, okay? What happened to the leg to get the hypotenuse? Well, the leg, we have to multiply by the square root of 2 to get the hypotenuse. So then think about what you'd have to do to work backwards. Well, to work backwards, we would have to do the opposite of multiplying by the square root of 2. So we would have to divide that by the square root of 2. So if you knew that, you could go ahead and jump to dividing that by the square root of 2. If that doesn't work for you, you can write the equation down. Since you're given the hypotenuse, we're going to write down the hypotenuse equation. So the hypotenuse is equal to the leg times the square root of 2. And now I'm going to plug in my information so that I can find my leg. Okay, so the hypotenuse is 21 square root 2. My leg, well, the leg I'm looking for is x. So I'm going to plug that in for the leg. And then I bring down this multiply by the square root of 2. Okay, so then to solve for x, we do the opposite of what's happening here. So since we're multiplying by the square root of 2, I have to divide by the square root of 2. And what I do to one side, I have to do to the other. Okay, and so these will go away, and I'll be left with x on this side. And then because I have a square root of 2 on the top and the bottom, that's the same thing as like 1. So this would be technically 1 times 21, which would be 21. So x, that leg, has a length of 21. And it didn't even ask us for the other side, but if it did, remember the legs are the same. So since this one would be 21, you would know that that other leg would be 21 as well. Okay, so let's keep going. All right. All right, so same setup. Notice this problem. You're asked to find a leg, and you're given the hypotenuse. And so, again, you can think through it. Well, what did I do to get the hypotenuse? I had to multiply by the square root of 2, so then I have to divide to work backwards. Or you can use the equation. So instead of writing the whole words out, I'm going to write an H for hypotenuse and an L for leg. So I know that handy dandy little property, the hypotenuse is equal to the leg times the square root of 2. And I'm going to plug in my information. So the hypotenuse is 15. I'm looking, notice I'm just copying my equation down. I'm looking for the leg. The leg is x. So I'm going to put an x for it. And then I'll multiply by the square root of 2. So to solve, work backwards, I have to divide by the square root of 2. And I have to do the same thing to both sides. Those will go away. So I'm left with x on this side, and then 15 over the square root of 2 on that side, okay? Now, here's the thing about these little rascals we call radicals, okay? Notice, and I'm going to switch this around. I'm going to put the x on the left side. Notice we have the square root of 2 on the bottom of a fraction. As a math person, you are not allowed to have radicals on the bottom of a fraction, okay? And so what you have to do when that happens and you end up with a radical on the bottom of a fraction is you have to do what's called rationalize the denominator, okay? And all that means is you are just getting rid of the radical that's on the bottom, okay? So if that's the only thing that's down there is just the square root of a number, so like in this case, you have the square root of 2, to get rid of it, all you have to do is multiply by that radical. So I'm going to multiply by the square root of 2 on the bottom of the fraction and the top of the fraction, okay? And that is what's called rationalizing. So I'll write it down, rationalizing the denominator. Okay, so when you do that, that's what you're doing, okay? And what you're really doing is just getting rid of the radical, okay? And so you'll notice that that'll actually do it for us. So on top, remember, you can't multiply the outside times the inside, so you just kind of leave it the way it is. So it'd be 15, and we don't typically write the little multiplication symbol between them. So this is the same thing as 15 times the square root of 2 on top. And then on the bottom, well, think about what we did yesterday. When we have inside times an inside, you just multiply them. So 2 times 2 is 4. And you leave it on the inside of the radical until you actually take the square root of it. Okay? And so now this top part will have to stay the way it is. Just because you can't take 15 times the square root of 2 without getting a decimal, and we don't want decimals in these problems. Okay? So it's going to still be 15 square root of 2 over, and then the square root of 4 is 2. Okay, now the last part of this, so I'm going to bring down my x. The last part of this is, notice this 15 and that 2 is now on the outside of a radical. If those two would actually simplify or reduce, then you would do that. But 15 over 2, if you think about that like a fraction, that won't reduce. So you actually have to leave that the way it is, okay? And so I know that looks like a mess, but that is actually the length of that side right there. And so x would actually equal 15 square root of 2 over 2. Even though it's a mess, that is the correct answer. Okay, let's do one more so you can see one more of how this works, and then you guys can work. All right, so this one, notice, same situation as before. You've got two sides the same. And by the way, something I didn't talk about, if two sides of a triangle are same, remember that means it's what's called an isosceles triangle. Okay. And so when you have that, that forces the angles that are opposite of them in a triangle to be the same as well. Okay, so those would have to be 45-degree angles. Okay, so notice in this one, you're given the hypotenuse, and the hypotenuse is crossed from that 90-degree angle, and you have to find the leg. So again, you can think about, okay, to work backwards, I have to do the opposite here, or you could use that handy-dandy equation. So the hypotenuse is equal to the leg times the square root of 2, and you can plug in, okay? So the hypotenuse is 24. The leg that I'm looking for is x, and then I'm going to bring down my square root of 2. To solve for x, do the opposite here. So the opposite of multiplying by the square root of 2 would be to divide by the square root of 2. You got to do it to both sides. These would go away, so I'm left with x equals, and I'm going to go ahead and bring this to the other side of my x, okay? So notice we have that not so fun radical on the bottom. So to get that radical off the bottom, just like what you did up here, we're going to rationalize the denominator. So you just multiply by that radical on the top and the bottom. On the top, you can't multiply the outside times the inside, so you just bring it over. And then on the bottom, the square root of 2 times the square root of 2 is the square root of 4. And then you can actually simplify that because the square root of 4 is 2. So we get 24 square root of 2 on the top over square root of 4 ended up being 2 on the bottom. And now, just like what I was talking about up here, because you have these two on the outside of a radical, if they simplify or reduce, you've got to reduce them. So 24 over 2 actually does simplify because 24 divided by 2 is 12, okay? So you just simply reduce them. So 24 over 2 was 12, okay? Think of it like a fraction. And then that square root of 2 doesn't have anything to simplify with, so it's literally just going to come down, okay? So that is what x equals, because you can't go any further with this without getting a decimal. So that would be the length of that leg. It would be 12 square root 2. All right, make sure to let me know if you have questions on the homework. Have a great day.